Hello everyone, I'm Petro Gnatyuk, GFT. I would like to present you the policy extraction demo. In CRISP DM methodology that we use, the policy extraction process maps to data preparation, modeling, and evaluation phases. In this demo, we're going to present a Lisbon pilot. We chose one Lisbon district, and the goal is to estimate the number of installed panels using aerial images and our trained model for detecting solar panels. To achieve this, we use a YOLO5 object detection framework, and we trained the model on our custom dataset. Let's have a look at the general flow of this process. There are 4 phases: data preparation, training, evaluation, and inference phase. Let's have a look at each of these phases and components to see how they're implemented and how they work. This is the label converter component. It's responsible for extracting labels from our dataset, converting them to format that is supported by the YOLO5 framework, and saving those images as a separate TXT files for every image. The next data preparation component is image splitter. It is responsible for splitting 5K or 6K images into smaller 124 pixels images, as it's required for our training algorithm. Let's have a look at the next main phase of our process. Having the data prepared, this phase does an actual training of the model. We start by getting all necessary YOLO5 source files, then we configure the dataset, specify all necessary paths and class names for object detection, and save the file. Next, we downloaded images, both training and validation dataset, and then we start our model training. This process took several iterations. The output of the previous iteration was used as a pre-trained model for the next iteration. This way we can achieve an optimal accuracy with the same amount of data. In the model evaluation, we can see 2 metrics. First one is an object loss, which shows the error rate for the object detection. We can see that with every iteration the error gets lower. And similarly, the second metric, the box loss, shows how close the box is to the detected panel. Finally, let's have a look at the inference phase. This is the last phase, and here we use Data Management API to retrieve images for one specific Lisbon region and run our inference process to detect and to estimate the number of solar panels in that region. Here we can see the result of this process. For every image, we can see how many panels were found. Then we calculate the general number of detected panels, which is 680. Then we can see some examples of detected panels. So here we have 7 detected panels. Here we can see 6 detected panels. Here it's 7. And here we can see 4 detected panels. The accuracy of the model still could be improved if we add to our dataset some label data from the Lisbon city. And that finishes my demo. Thank you everyone for your attention.